Hey City of Coquitlam, welcome to Science for Children. Our theme today is light. All of our experiments are going to be dealing with light and some of the interesting reactions that we can get from it. We're going to be doing 3 experiments today. For your first experiment, you're going to need a clear bottle filled with water, a pencil, any color or size will do, a dark marker, and a Post-it note. All right, let's get started with our first experiment here. So what we're going to be testing here is light refraction. So the question that we're going to be asking is, will the image that we put on the Post-it note change when we put it behind water? Let's get set up. So the first thing we're going to do is take your dark marker and one Post-it note. And what I want you to do is draw 2 arrows, one going in one direction and one going in the other. You can make them quite dark. You want to make it really obvious which one is going in which direction. If at any time in this video we're going too fast, feel free to pause and catch up and then play when you're ready. So when you're finished, your Post-it note should look something like this. You should have one arrow going in one direction and one going in the other. Now, when we look at it this way, this arrow is going that way and this arrow is going that way, right? We can all see that. Now, I want you to take your water bottle. You're going to put it about this far in front of you. Now, you're going to be looking at it towards yourself. I'm going to show you towards the camera. So remember, the top arrow is going in this direction and the bottom arrow is going in this direction. Now let's see what happens if we put it behind the bottle. Now there's something crazy going on here. If you're noticing this yourself, is as soon as I put the Post-it behind the water, the arrows have switched direction. Are you getting that on your side too? Let's try again. Remember, if you're not sure, take a look at what direction your arrows are pointing. Isn't that amazing? All right, we're gonna put the Post-it note to the side for a moment. And now we're gonna get our pencil. So we can see here that our pencil is nice and straight. What's gonna happen, do you think, when we put it behind the water? Seeing what happened with the arrows. Let's find out. Now, if you can see on your end, the pencil has bent in a really strange way. Now, I'm putting my pencil in nice and straight. But you can see what happens with the light here. It's bending it. Now, if we put our pencil up even more straight, it actually disappears. My pencil's right here though. But when I hold it off to the sides, the pencil disappears completely. Can you see that on your end? Isn't that interesting? The most basic ingredients, and we're doing our first science experiment. So the concept that we're working on for this particular experiment is called light refraction. So what happens is light bends when it's passing through some substances, such as water or plastic, which we have both of here. What happens is it travels through the substance is light becomes concentrated in one small point, which we call a focal point, which is usually near the center. So as it passes through the focal point, the light rays crisscross over each other, which is causing the image to appear reversed. Just like with these arrows here, the arrows seem to be going in opposite directions, but in reality, they're not. Same thing with the pencil. When we put our pencil here and we put it off to the side a little bit, it almost seems to disappear because it's so far out of the center focal point, the light can't concentrate on it at all. You can try this experiment with all sorts of things behind and see what happens when you put things behind your plastic water bottle. How much do they change? You can also try drawing different images on a Post-it note or a piece of paper and putting them behind and seeing what kind of reflection you're going to get. All right, let's move on to our second experiment for today. For this particular experiment, we're going to be making a homemade spectroscope. And a spectroscope is a special tool that we use to see the spectrum, which you may know usually as the colors of the rainbow. For this experiment, you're going to need a paper towel tube. If you don't have a paper towel tube, you can also tape about 3 toilet paper rolls together. That will work fine as well. So a paper towel tube that's empty, a CD with at least one side that's shiny. This can be an old one or a blank one. We need a pair of scissors or a craft knife. So for kids who are about 5 and under, you may want to have a little bit of help from mom and dad for this one. We need tape, and we need a little bit of paper. I'm using cardstock because it's a little bit thicker than typical paper, but regular paper will work just fine. So the first thing we're going to do to make our spectroscope is we're going to take our scissors and our knife. And what we're going to do is we're going to make a slit in the side to put our CD in. So we want to go at about this angle on a cut, about this far from the bottom. So what I'm going to do is fold my paper towel tube this way, and I'm going to cut on a bit of an angle here. Make sure that you don't cut all the way through your tube, or else it won't work. Perfect. So this is what mine looks like right now. You can see that we've cut a little piece of the tube off. Perfect. Now, looking at where the end of your line is, go directly to the opposite side. So for me, if this is the cut, the opposite side is going to be right here. We're going to cut a small rectangle. This is what we're going to use to see. So I'm going to cut 2 lines, and then I'm going to cut across to make a small slit. So it should now look something like this. So our front side, we have this slot here for a CD, and on the reverse side, our cut right here. Now, the next thing we're gonna do is you're gonna take your cardstock paper and put it down. We're gonna take the top end of our paper towel tube. So these pieces are at the bottom. We're gonna take the top and we're gonna put it face down, and we're gonna trace the circle shape. It doesn't matter if you have any pencil or pen lines showing, it's not going to affect the experiment. So now we're going to take our scissors and we're going to cut that shape out. This is an experiment that works really, really well on a sunny day, but if you're watching this video and it's not so light outside, lights in your house will work just fine too. So now we have a small circle that we've just cut out. What we need to do is cut a small rectangle out of the center. So what I like to do is fold it in half, like so. We're gonna make a slim cut here and here. So 1, 2, and then we're gonna cut across. So that our circle now has a rectangle inside. Now what we're gonna do is get our spectroscope back, and we're gonna tape this piece to the very top that we traced. We wanna try and make sure that no light gets in except for that rectangle. Good, so this is what it looks like so far. I've taped it on 2 sides. I'm gonna tape it on the other 2 sides as well to make it a little bit more secure. And if you want, you could of course decorate your spectroscope. You can paint it, you can put glitter or stickers on it, whatever you want to do. For today, we're just showing you the basic. So when your spectroscope is finished, what it should look like is a paper towel tube with a piece of cardstock or paper and a rectangle cut out of the top, a rectangle on the bottom, and a diagonal slit for our CD. What we're gonna do now is take our CD and we're gonna put the shiny side up and insert it into that slit that we cut. If you find that it's ripping a little bit, you can always tape it. That's what tape is for. Let's get that back in. So, when finished, your spectroscope should look something like this. Our CD should be coming out at an angle with the shiny side up and the paper at the top. So we're gonna go outside and test this, but you can also test this here in your own home. What we wanna take a look at is what's gonna happen to the reflection of the CD from inside the tube. Okay, so we have moved outside. We have our spectroscope with us here. One thing to note with your spectroscope, if you find that it isn't quite working for you, make sure that where you cut this part here is directly in line with this CD angle. If you cut it a little too low or too high, it's gonna be hard to see the reflection that you want. So let's take a look. So we're gonna angle this top part up towards the sun. It's a beautiful day outside. And then we're gonna close one eye and then look through our spectroscope, and you should hopefully be seeing some different light patterns. You can try tilting your spectroscope as well to see some different. In mine right now, I see a lot of blues and greens. That could change depending on the time of day. So change the angle of your spectroscope, move it around a little bit. See, if I look over here, I get more yellow and orange and red. Moving it side to side. And just test it out and see where you're gonna get the best light refraction from. So keep giving that a try, and then when you're done, we're gonna head back inside and we're gonna talk about how this happens. Did you see anything interesting? What we should have seen was some light spectrum. So what that means is, we can even see it here with the CD under the light, that it's reflecting a little bit of rainbow. Now what happens when we go outside and we put it in direct sunlight is we're bouncing the light off of the CD and refracting it inside. So from going outside, what we've determined is that yes, we can see different types of rainbow spectrum inside. If you noticed outside as well, if you moved your spectroscope around, your reflection or refraction was changing, and you could see probably different types of light. So the reason why this happens, so the science behind it, is a CD is a mirrored surface with spiral tracks on it that are evenly spaced out. And what they do is they diffract light, which we can see here. Now diffracting means separating the colors. So we can see here, there's some different colors here and some different colors here. Now a CD surface is also mirrored, so that light gets reflected into your eye when you put it into a spectroscope. Pretty cool, hey? All right, now we're gonna move on to our third experiment for today. This one, we don't need too many materials, but we are gonna take a little bit more prep time. So we're gonna take that same CD. We also need our scissors. We need our tape, and we need some basic paper. So basic paper that you might find in your printer. This one's a little bit thinner. So what we're gonna start off by doing is explaining what we're gonna be looking for in this experiment. So we're gonna be practicing some different types of CD reflections. Now, what we're gonna do with the paper is we're gonna cut out some different shapes. Some of you might be used to making paper snowflakes around Christmas time or around winter. We're gonna try something similar now and see what happens when we put it on a CD with a light source hitting it. So, what do you think? What will the reflection look like when we put the snowflake on it? Let's try. So, you can make as many of these as you want. And what we're gonna do is we're gonna put the CD down on a piece of paper and we're gonna trace around the outside. We're gonna cut out that shape. Now, it's okay if it's not exactly right, that's fine. So from here, we need to cut some shapes into it. Now, I like to cut mine like a snowflake, so we're gonna fold our circle in half, like so. So we have an open end here, good. From here, from about the middle point, you're gonna fold over about 1/3. So we're going from here to here. Then this piece goes over top. So now all 3 layers are on top of each other. You want to make sure that they're fairly even as well. So now we have what looks like a tiny piece of pizza. So the important thing to remember is you want to keep parts of the edges together so that it will stay connected. So let's start. We're going to start by cutting some random shapes in here. So I'm going to start by putting a cut in the center of my snowflake. Then I'm going to do some zigzags on the side. So this is what mine looks like so far. I'm going to do some on the other side too. Good. Again, this is where we're at right now, and maybe a few along the top. Okay, so notice that it's all still together, but now we have some cutouts in here. So let's get those paper scraps off the table, or at least brush them to the side. All right, so now time to see what this paper snowflake is gonna look like. So we're gonna open it up, 1, 2, and then open it up all the way. Now, this is perfect. Notice it's all still connected, but we do have some cutouts in here. So we can gently press it flat. Then we're gonna put our CD with the shiny side up and lay our snowflake on top. So it looks like this. We're gonna take our tape and we're gonna gently tape our snowflake pattern to our CD. Doesn't have to be super tight. It will work just fine. So now your CD should look like so. And what we're gonna do is we're gonna test with a light source. And ideally you wanna have a blank wall or ceiling even, that will work too. And we're gonna see what happens. What's gonna change here with flashing some light onto our CD now that we have a pattern on it. All right, we're back outside and we're going to test our CD with our snowflake pattern over top and see what happens. So I can actually see way down below here, my CD's already catching some light and casting a few light rays, which is quite cool. So we're gonna try it here and see if we can see anything on the wall or the roof. So here we've got the CD, we've got the sun above us here. We're gonna try and tilt this until we start seeing a reflection on the wall. You can see that the reflection looks quite different because we cut out all of those shapes. What's interesting is there's actually two. Do you see both of them moving? All right, did you give it a try? Awesome. So the reasoning why this happens, or the science behind it, is similar to the experiment that we did before with the spectroscope. Because a CD is a mirrored surface, it's gonna refract or diffract different types of light, AKA colors. So what happens with the paper is the paper blocks some of the light rays from the CDs, like here, but lets others through, like these shiny parts here. And therefore it's gonna create those interesting shapes that you saw outside or on your wall. Thank you so much for joining us today. We really hope that you learned something new, and we'll take this science perspective with you into your daily life. The important thing to remember is science is everywhere. You just have to know how to look for it. We hope to see you next time. Bye.